This is Autohaus Hamilton TV. I'm James, and today, come up to the lab and let's see what's on the slab. Today I'm going to be talking about relays. What is a relay? A relay is simply a switched switch, and you'll get to see more about what I mean by that in a little while. A relay's job is to do electrical heavy lifting. Without relays, the current in a circuit would always go through the switch. It has to. When you switch on the light switch in a room in your home, all the electricity on its way to the light bulb goes through the switch. That's just the way it's designed and the way it works. In a motor vehicle, there are enormous differences in current between different appliances. And as an example, on the one hand, you've got the horn, which uses hardly any power at all. And on the other extreme, you've got the starter motor, which uses a significant current indeed. So you might get away with having all the current required for the horn going through the horn switch, but if you try to put all the current that your starter motor uses through your ignition switch, which is normally a lightweight thing, then you'd end up frying your ignition switch. So to get around that, circuit designers use relays, and we've got a relay here. We've got a couple of other things. We've got a battery to supply power. We've got a switch, which puts me in control. We've got a light, which is going to be the object that we're going to be powering through the switch and through the relay. So at the moment, the way things are figured up, I've got my power side of the relay is disconnected, although the relay is connected via the switch. And if I hit the switch, you should be able to see this part of the relay closing. And I'll explain that in a second as well. So I hit the switch and the relay closes. I switch the switch off and the relay opens again. So this is a relay that I've sawn the top off so we can have a look at its inner workings. There are two circuits at work here. One is the circuit that's controlled by the switch, and when I hit that switch, as we've seen, it works the relay. And the other circuit is the circuit that the relay itself controls. So what happens? I hit the switch. Hitting the switch powers up an electromagnet that is the main part of the relay, and that pulls this contact closed, and with that contact closed, that would then allow power to work its way through to the light. Now I've left the light disconnected because it's more than the cameras that I'm using can handle in terms of light contrast. But just to show you what happens, we'll switch things off again. We'll connect the active part of the circuit to the battery. And now when I switch on the switch, we have a great deal of light coming out of that light bulb. This might be a case for keeping your light under a bushel, so I'm going to once again disconnect the light. So I've said that we want not much current going through the switch to let all the current go through the light bulb. That's, I think, a 35 watt light bulb, which means, if I remember my high school science correctly, we've got about 3 amps going through the circuit, through the part of the circuit to the lamp. And we can do a kind of quick and dirty test on that. I've got here a 1 amp fuse. So we'll try the 1 amp fuse first on the low current side of the circuit. We'll switch things on. And that, you can hear the clicking. That's the relay being switched on. So that's happy to work. We'll connect the lamp back to the power. And that's happy to light up that light bulb for as long as I want it to stay lit. That's using the fuse on the low current circuit. So now if we switch things off and turn things around, we're going to connect the relay up and we'll put the fuse. So now the fuse is between the battery terminal and the light bulb, and we'll switch things on. So the circuit only becomes active. We've got the circuit to the relay active, but the circuit to the light's only going to become active when I touch this against my Bulldog electrical connector. And if you heard that click was the short and rather brutal life of that poor fuse. So that's the basics of how a relay works, what it does, and this is just a very basic relay. Those of you that drive a 3.2 Carrera or a 964 or a 993 may know of a mysterious thing called a DME relay that sits beneath the passenger seat, and the DME relay is the relay that controls the Bosch Motronic system that runs the whole car. So that's a slightly more complicated relay. Relays can also be designed in circuits to do more clever things, because a relay, being just an on-off switch, is essentially a binary device. In fact, the very first computers were nothing more than a collection of relays. So they had a state of either on or off, which would be the 1 or 0 in a binary system. And in fact, the term bug comes from those very early days where one of those very basic computers wasn't functioning correctly. Somebody was sent to investigate the problems with the relays, and they duly reported that they found a bug. And the bug that they found was a moth that had been squished between the contacts of the relay. That's the only known example of the fields of entomology and etymology coinciding. As ever, thank you very much for watching. Hi, this is Autohaus Hamilton TV, and the camera is skew.